Again, formal charge is used to evaluate non-equivalent Lewis-Dot structures. We'll see some examples. So, atoms in molecules try to achieve formal charges as close to 0 as possible. So any negative formal charges are expected to reside on the most electronegative atom. Atoms. So we'll learn how to calculate formal charge on atoms in a molecule. So this is about why we use formal charge and what it gives. Which one we consider? Usually we know that if formal charge is close to 0, that most of the atom they try to achieve that. So that's when we are looking for close to 0. And if we have more electronegative atom, then the negative formal charge is around that atom. Alright, so now let's calculate formal charge, and I will give you a few examples. So formal charge equal, first, formal charge equals, I'm going to write a number of valence electron on free neutral atom
Is that a C? Oh, it's
minus number of valence electron assigned to the atom in the molecule. So you can see this is for neutral atom and this one is in a molecule. Alright. Now what we need to assume in this case, by applying this one we need to assume, so we can assume that lone pair electrons belong entirely to the atom in question. We'll work on one of the examples. And shared electrons are divided equally between two sharing atoms. So that's assumptions that we need to follow. Now, we are going to work on example, and I think I will show you the steps and then parallelly with examples, so that way we can work on that. So, to calculate formal charge on an atom, first what we need to do, take the sum of the lone pair electrons and 1/2 the shared electrons. So that's the first. First, we do that, sum of the lone pair electrons. So let's see, I'm going to give you an example. We need to first draw Lewis dot structure of POCl3, and then we need to assign formal charge. Of each atom in a molecule. So first step in this case, we need to draw Lewis dot structure of POCl3. So when you draw POCl3, oxygen, chlorine, chlorine and chlorine, and we place dots. Now we know how to draw Lewis dot structure of molecules. All chlorine, oxygen. Okay. So each chlorine, oxygen, they have 6 6 around them and 1 1. Now according to this step, first sum of the lone pair electrons and 1/2 of the shared electrons. Now first let's talk about for phosphorus. Is there any lone pair electrons on phosphorus? No. Okay. How many shared pair of electrons in them?
4.
4. 4 shared pairs. Okay. And the 1/2 of the shared pair, so we can say 2 shared pairs according to these steps, right? Now let's go for next step. Okay, so I'm going to write for next step. Subtract the number of assigned electrons from the number of valence electron on the free neutral atom. Okay, Now when you look at it here, there is no lone pair here on here. So again, if we don't follow step 1, we can again write for Lewis dot structure of POCl3 and follow these steps. On phosphorus, first tell me how many valence electron on a neutral phosphorus. What group it is?
5.
And how many valence electrons?
5.
5, because phosphorus itself, neutral phosphorus is in group 5, so valence electron in neutral is 5. Now shared, okay, number of assigned electrons. So again, when we see shared electrons, we have shared electrons. Here we see 4, but then when we find it's a 2 pairs, right? So how many shared electrons?
4.
Yes, shared electrons are on phosphorus. We are talking about particularly for the phosphorus is 4. Okay, so 5 minus 4. So 5 minus 4, you get formal charge on phosphorus plus 1. So we can say on phosphorus plus 1. Now let's talk about for oxygen. I need to erase this side so I can write for oxygen. Now let's talk about for oxygen. Oxygen has 6 valence electron in a neutral oxygen minus, we have shared electrons, how many?
1. 7.
7.
1.
Hold on, just a minute. Let me go back. Valence electrons assigned to the atom in the molecule. Okay, can we calculate? Can we follow this one and calculate? Valence electron on a free neutral atom minus valence electron assigned to the atom in a molecule.
So it's going to be 6 minus.
It's going to be 6 minus 7, so which is going to be -1. And for chlorine, we have 7 valence electron and 7, so which is going to be the 0. So now, remember, what's the rule for the formal charges? So I'm going to go to the next step. The sum of the formal charges of all atoms in a given molecule or ion must equal the overall charges on that species. So that means what we do? We do add sum of all. We calculated for phosphorus is +1. We calculated oxygen is for -1. And then chlorine is 0. When we add the sum of the charges, you get 0. That will tell you that POCl3 has 0 charges on that species. Overall charge on that species is 0. When you add all the formal charges on an atom and then you add them, that will get you the overall charges on that molecule.